What's going on, guys? Let's see how we can do this problem right here. The question is asking use the shell method to determine the volume formed by the bounded region rotated about the x-axis, and the bounded region is given by this expression. Let's draw the graph for this one, right? So let's see how the graph is going to look like. So first of all, we have an y square. So we know that that's a parabola opening up because it's positive x square, so it's going to be like this. But before that's just going through the origin, so we don't have to worry anything about it. So this is going to be our parabola, y is equal to x square, and they are saying this is going from y is equal to 0, then x is equal to 2. So let's say this is 2 right here. So if this is x is equal to 2, this is going to be the line. So 2 right here, the region we are interested in is this region, bounded by these two curves. So this is the region. So this is the volume of the region we are trying to find. And also they have mentioned this is rotating around x-axis. So in shell method, if something rotates around x-axis or parallel to x-axis, we have to write everything in terms of y. So here we are going to write the volume equation in terms of y. So this is going to be v is equal to 2 phi going from C to D, ry, r is radius, height in terms of y, dy, right? So this is the equation we are going to use. So here we have to find the radius and the height in terms of y. So let's see how we can find the radius. So whenever we have the axis rotating around x-axis, we have to draw a rectangle that is the height is parallel to that rotating axis. So here it's rotating around x-axis, so we have to draw the height parallel to x-axis, right? So this is going to be our rectangle, and the radius here is going to be this height from here to this one. So this is our radius, and also from 0 rotating region to the rectangle is going to be radius, and 0 to the rectangle is going to be y, right? Here both of them are equal, r and y are equal, so that makes this easier. Now let's see how we can find the height. So we know that from 0 to distance of this rectangle is going to be y, right? And the height of this rectangle is going to be this distance from starting of rectangle to this rectangle. So that's going to be the height, and we know this total distance is 2. From 0 to here is 2, right? And if we want to express in terms of y, we can write like h is equal to 2 minus y, right? If you subtract this from this, that's going to give us this distance. So h is equal to 2 minus y. So we have written h in terms of y, but we know that r is equal to y. You know what? This is x actually. If it's in x-axis, this is x. So this is x. So this is the one we have to change. H is 2 minus x. R is y. So here we have r already in terms of y, but we have to change the h in terms of y. In the given equation, we have y is equal to x square, but we have to find x is equal to what value. So if x square is equal to y, x is going to be root y. That is same as y power half, right? So we can go ahead and plug in terms instead of x. Instead of x right here. So h is going to be 2 minus y power half. Now we have everything in terms of y. Now let's go ahead and plug it in the equation. So we have this equation, v is equal to 2 phi. So CD value is going to be, when we write this one in terms of y, the CD value is going to be the y distance. So from the region that's starting from 0, and this height right here. To find this height, we know that this is at x is equal to 2 at this location, and we have to find the value when x is equal to 2. What is the y value? If you plug it in this equation, that's going to give you y is equal to 2 square, and that's going to be equal to 4. So here the y value is 4. So the limits of integration is going to be 0 to 4, right? And ry, we know that radius is y, and then we know the height is 2 minus y power half. 2 minus y power half dy. Now let's do the multiplication. If you multiply, we get 0 to 4, 2y minus 1 plus half, 1.5, same as 3 by 2, right? 3 by 2 dy. Now we can do the integration. If we integrate this one, that's going to give us 2y square divided by 2 minus y. So if we add one more to the power, that's going to give us, it's same as adding 2 by 2. So that's 5 by 2. Y power 5 by 2 divided by 5 by 2. Instead of writing 5 in the 2 in the denominator, I can bring it and multiply here. So here we multiply that one, and that's going from 0 to 4, right? Let's substitute 4 first. So here maybe different color. So 2 times 4 square. You know what? We can cancel these 2 before we add them. 2 cancels. So this is just going to be 4 square. 4 square minus 4 power 5 over 2 multiplied by 2 divided by 5, going from 0 to 4, right? So we already substituted 4. If you substitute 0, this is just going to be 0, because if you substitute y 0 for y, that's going to be 0, and minus this is also going to be 0, so we can just write minus 0. Let's go ahead and simplify this one. So here we are going to have 4 square is going to be 16 minus 4 is same as 2 square, right? So if I write 2 square power 5 by 2, this 2 cancels, and we have 2 multiplication. So let's see what we get. Also divided by 5. So this is going to be 2 multiplied by 60 minus 2 power 5 is going to be 32. 32 times 2 divided by 5, and let's simplify this one. 2 multiplied by, so we have 64 right here. So this is 5 times 16, that's going to be 80. 80 minus 64 divided by 5. So that's going to give us 16. So 2 times 16 divided by 5, that's going to give us 32 5 over 5, and that's going to be the volume of this shaded region. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.